The GPA pointer calculation system is a straightforward C++ program that helps students calculate their grade point average GPA based on their performance in each subject. The user enters the number of subjects, the credit hours for each subject, and the grade points received. The system then calculates and shows the overall GPA using a standard weighted average formula. The system aims to make the GPA calculation process easier. Many students typically do this manually, which can be tedious and lead to errors, especially with multiple subjects. By automating the process, the system offers better accuracy and saves time. Besides the C++ program, the logic is also converted into assembly language. This gives students hands-on experience in low-level programming and the instruction cycle of a computer, reinforcing important concepts in computer architecture and digital systems.
In this slide, we will discuss about the program code C++ is the assembly language. The C++ program is designed to calculate a student grade point average GPA based on the number of subjects. The grade point earned and the credit hour for each subject. It begins by promoting the user to enter the number of subjects. Then using a for loop, it iterates to each subject and asks the user to input the grade point and the credit hour. Inside the loop, it calculates the total grade point by multiplying each grade point by each grade hours and add the result to the total point. At the same time, it accumulated the total credit hours in total credit. After all subjects are processed, the program calculates the GPA by dividing the total grade points by the total credit hour. Finally, it displays the calculated GPA to user using count. This program using basic concept using a variables, loop, user input and arithmetic operation to perform GPA calculation effectively. For the assembly language program written in NASM synthetic for Linux using x86 architecture is designed to calculate the grade point average GPA of a student based on the number of subjects. The grade point obtained for each subject and comprising credit hour. The program begins by declaring necessary constant message and formatting string in the data section, which are used for formatting the user and formatting the output. In the .bss section, several variables are declared to store user input such as number of subject and individual grade point and grade credit hour, as well as accumulated total like total point, total credit and the final calculate GPA. A loop begins in a literate over each subject. In each interaction, a program promotes the user to enter the grade point and credit hour for subject. Next, the program performs the floating point arithmetic using an x36 FPU floating point unit. It multiples the grade point by the credit hour and adds the result to total point. Then add the credit hour to total credit. This process continues until all subject has been processed. After exit the loop, the GP is calculated by dividing total point by total credit using floating point division. The result is stored in the GPA variable. Finally, the program print the GPA result using printf and exit cleanly using a Linux system called in0x80.
Next is about the instruction set. We are using 15 different instructions for this assembly language. First is MOV instruction. The purpose is to move data between register and memory. We are using data transfer type for it. Second is push. Its purpose is to push values onto the stack for function arguments. We are using call type. Next is call. For call external functions such as printf and scanf, we are using procedure control type. Next is add. Add we are using it for adjust the stack pointer. We are using arithmetic type. Next is CMP. We use CMP instruction to compare two values. We are using comparison type. The next one is JGE. This is to jump if greater or equal value. We are using conditional branch. Next is INC. We are using it for increment a value. We are using arithmetic type. JMP for unconditional jump using unconditional branch, and FLD load a floating point value. We are using FPU instruction type. Next is FMUL. This is to multiply top two FPU stack values. We are using FPU arithmetic. and then FADD to add top two FPU stack values. We are using FPU arithmetic as well. The next one is FSTP. It is to store value from FPU stack into memory and pop it. We are using FPU store type. The next one is FDIV. Divide the top two FPU stack values. We are using FPU arithmetic type to solve this. The next one is INT0 times 80 to make a Linux system call. We are using system call type for it. The next one is XOR, which is to clear a register using logical operator type. Next is about instruction cycle. There are three, which is fetch, decode, and execute. Fetch meaning retrieve the instruction from memory. Decode meaning determine what the instruction is and which operand it ends. And lastly, execute performs the action, arithmetic, data transfer, comparison, or jump. As I have told, we are using 15 instruction. So MOV, the first instruction, uses fetch, decode, and execute to move data between memory and register. Second, push instruction uses fetch, decode, execute as well to store value on the stack. Third is call instruction. It fetch, decode, and execute, then jump to subroutine. It is to call printf or scanf. The fourth one is add, which uses fetch, decode, and execute. It uses arithmetic operation. CMP is to compare values, update processor flags. JGE uses fetch, decode, execute, possibly fetch again, then jumps to label if condition is true. It also affects control flow. INC uses fetch, decode, execute for increment the loop counter. JMP fetch, decode, and execute for unconditionally jump to another instruction. FLD loads a float from memory into FPU stack, and FMUL multiplies TP FPU values. It's like grade times credit. FADD uses fetch, decode, execute cycle stage to add stop FPU values. Next is FSTP. It uses fetch, decode, execute as well to store FPU result into memory and pops the stack. 14th is FDIV. Uses fetch, decode, execute to divide two FPU values such as CGPA equals to total points divide total credits, and INT 0 times 80 uses fetch, decode, execute system interrupt to make system calls to exit program.